Math 113, Lesson 7.3 covers polar coordinates. Now, rectangular coordinates are what we're used to working with, and ordered pairs are typically x and y. But in the polar coordinate system, our ordered pair would be r and theta. And theta is going to be in radians most often. Okay, so when I look at the polar coordinate system, there's a couple of things that are super important. All right, so the first thing is this point right here. We call it the pole. And then we have this ray that goes to the right, like the positive x-axis. This is called the polar axis. Now what happens from here is we have, let me draw them in a different color because they're not really a part of the graph. I'll draw them in gray. All right, so from here we have circles. Like on the rectangular system, we have lines to help us out. The polar system, we have circles. So this would represent 1, 2, 3, just like on the x-axis. Now, there are not negative values here. All right, we're just talking about the first circle, the second circle, the third, the fourth, the fifth. Okay. Now, the other thing that is measured is angles on your polar coordinate system. So if I imagined this pole, let me go back to black. If I imagine, now that pole and the polar axis are always there, and that is their location. Now I am going to draw for you a not very straight dotted line. If I extended that the other direction, then what I need to be thinking is the value there is 0. The value over here is pi. Okay, so I can have some angle. Let me just draw it over here before I try to put it on the graph. So again, there's our polar axis. And here's our pole. And when I draw some angle, what's going to happen is there's going to be this point whose ordered pair is r theta that is formed by drawing some angle theta. All right, so we need to make sure we understand what r actually represents. R is the directed distance from the pole. To that point P. Okay, so r is the directed distance from the pole to point P. And then theta is an angle, just like I've drawn right there, from the polar axis to the line segment from the pole to that point P. All right, so I've got that diagram drawn for you. So now I'm going to put one on the actual polar coordinate system that I have drawn over here. Let's say I graph for you the ordered pair 2 pi over 3. So before I do that, another thing that often is on the polar grid is they will kind of mark for you, and I'm going to do it in gray because it's not really a part of the graph. They will mark for you, just like on the unit circle. We know this is pi over 6, pi over 4, pi over 3, and then those values continue in every one of these, if you will, thinking of x and y axis, quadrants, but they are not quadrants. The polar system, we do not have quadrants. We've got this pole and the polar axis. And then everything that's in gray is just kind of a guide to help you know where you are. All right, so let's go back to graphing my ordered pair 2 pi over 3. Now 2 represents my r value, and that tells me what circle I'm on. All all right? And then pi over 3 tells me what my theta value is. So if I am on the second circle at pi over 3, then that would be my point right there. That dot is my point. All right? That's not so bad. So let's try a few. Show you how we can sketch out a few of these. All right, so we are going to graph these polar points. We're going to graph 315 degrees. Now, these will not usually be written in degrees. Most often they will be in radians. Okay, so let's just start with this first one. All right, so I've got my pole and my polar axis. Now, since this says that my R value is 3, then that means I'm definitely going to be on the third circle. Okay, so I'm going to draw 3 of them. So I'm definitely going to be on the third circle at 315 degrees. Well, 315 degrees, if I start on the polar axis and go all the way around to 315, that would put me about right here. So there's my point, 315 degrees. Okay, now B is a little different because my R value is negative and distances are not negative. So that little R value right there, that means we are going to do something different. All right, means go across the pole. All right, now before I do, that's not the first step. All right, but first, let's graph 2 pi. All right, let's graph 2 pi. And I'm going to graph 2 pi in green. Okay, let's graph 2 pi. All right, so I'm going to draw myself a little polar system. So I've got my pole, my polar axis, and we're definitely going to be on the second circle. So I'm going to draw 2 circles for sure. All right, and 2 pi, I said I would graph this one in green. If I go pi starting at the polar axis and I go a radian of pi, that would put me right here. So this is 2 pi. This is not what we were asked to graph. Okay, we were asked to graph negative 2 pi. So we chose, first we graph 2 pi. Now we go across the pole. So if I am sitting at that 2 pi, that green dot, and I go directly across the pole, it puts me right there. That is negative 2 pi. All right, so the green is not our answer. Only the red point is our answer here. Okay? So our next one says -1, negative pi over 2. Okay, so I'll start with my pole and my polar axis, and we're just going to be on the first ring. Okay, so because it's a 1, my R value is a 1. All right, so again, we've got that negative. So first, we are going to graph 1 negative pi over 2. Now, the radian, we can graph that negative. Okay, so when R is negative, we're going to graph it as if R were positive. Again, I'm going to do that in green because this is not my answer. All right, so if I'm on the first ring and I go negative pi over 2, I start at the polar axis, negative pi over 2 would put me right here. So this is 1 negative pi over 2. That is not what we were asked to graph. So now to get to -1 negative pi over 2, I go across the pole. And that puts me right there. -1 negative pi over 2. So the red dot is definitely my answer. Okay, so just like on the unit circle, if I talk about the location of a point at pi over 4, I could go around the circle multiple times and still end up at the same spot. Well, that's also true in polar coordinates. We can have multiple representations of points. In other words, they have more names than just one. Okay, so if I've got this point r theta, I also could call it r, and I could go around the circle a whole time, 2 pi n. Okay, I could go around the circle however many times I want. That the n value determines how many times we're going around the circle. And this would give me a new point, but it represents the exact same location. All right, or I could say, you know what, I want to go across the pole, but in order to do that, I need to add pi, and then I can go around the circle however many times I want. Now that looks a little confusing. Let's do some of these so you can actually see that in action. So we are going to find another representation of 5 pi over 4, in which, and then I'm going to give you some different options here, some different questions. So first, let's say I want you to give me one where r is positive and our theta value is somewhere between 2 pi and 4 pi. Okay. So here's what I'm going to do first. First, I'm going to figure out where is that ordered pair 5 pi over 4. So I've got to have 5 circles. 1, 2, 3, 4, 5. Not very precise there. Okay, so if I first graph 5 pi over 4, I've got to be on the 5th ring at pi over 4 is about right here. So this is 5 pi over 4. That is not another representation. That is the point that they're talking about. So I want another representation. I want my r to remain positive, but this time my theta has to be bigger than 2 pi, but smaller than 4 pi. Really, all that means is go around the circle a whole time and get back there, and what will it be? So this is the one where we add 2 pi. So 5 doesn't change, but I want to add 2 pi. Just go around the circle once. And so my ordered pair is going to be 5, 9 pi over 4. All right, so another way to name that point is 5, 9 pi over 4. All right, next question. Still working with that first angle. Sorry, the first point, 5 pi over 4. This time I want r to be negative, and I want theta to be between 0 and 2 pi. Okay, so again, I'm going to start with where that is located. Now, instead of having to draw 5 circles, I'm going to do like this. 1, 2, 3, 4, 5. Okay, that represents the 5th circle. Okay, and pi over 4 would be about right here. So this point is 5 pi over 4. Now, they want us to name that same point, but use a negative r. So here's the way I think of that. If I were naming this angle over here across the pole, okay, if I knew that angle, I'm sorry, didn't mean to put a negative there. What do I know about that? I know that for sure that point is still on the 5th ring. And now, what is the location of its radians? Well, it's pi away from this one that was already given to me. So pi over 4 plus pi. And that will name the point that we're looking at right now. And so that point is 5 pi over 4. That's this green point right here. 5 pi over 4. Now I want to name the black point, but I want it to be a negative r. So if I took this green one and I went across the pole, then that would be negative 5 pi over 4. If you use our little formula up above, notice it said you can change this to a negative r and add pi, or you could also go around the circle however many times you want plus 2 pi n. But our directions wanted our theta to stay between 0 and 2 pi. Okay, one more. If r is positive, go back to r being positive, and I want theta to be somewhere between negative 2 pi and 0. Okay, again, I'm going to start with 1, 2, 3, 4, 5. So this represents my 5th circle. This is the point that we are given, 5 pi over 4, and we're looking for another representation where r is positive, but theta is a negative value. Okay, well, if I just go the negative direction from here, from my polar, if I go this direction to name that angle, that would make theta negative, right? So, still on the same point, 5, I want my r to be positive, right? And to find out what that blue theta would be, I just say 2 pi minus pi over 4. I wrote that backwards. Pi over 4 minus 2 pi. Okay, and I get negative 7 pi over 4. So now theta is negative. That is the correct theta. And we're on the 5th ring. R is 5. So different representations of the exact same point. Now, I mentioned at the beginning the rectangular coordinate system, so let's relate our polar to rectangular coordinates. Remember, rectangular are x, y, polar are r, theta. So how can we relate them to each other? Like how will that work? Well, I know I can name this point P 2 different ways. I can name it r theta in our polar coordinate system, right? This would be r, theta would be this angle. Well, if I represent this in my rectangular coordinate system, it looks like x and y. Now the problem is you can't just say r is x and theta is y. That doesn't work. Right? That doesn't work. On our unit circle, our r value was 1. Okay, on the unit circle, r was 1. And so on our unit circle, we said x was cosine theta. And we said y was sine theta. That's on the unit circle. Well, we are no longer on the unit circle, which means that our r value is not going to always be 1. Okay? So, when we're on the polar coordinate system, our x value is whatever the value of r is times the cosine of theta. Our y value is whatever that value of r is times the sine of theta. Very similar to what we did on the unit circle, but on the unit circle, our r value was just 1 both times, so it looks like we didn't use it, but we did. R squared is x squared plus y squared. That part hasn't changed. And another thing that hasn't changed is we know to find the tangent of theta, we put our y value over our x value. That has not changed. And we need to make sure we're thinking of theta in radians. Okay, in the polar system, theta is going to be in radians. All right, so let's use this information. I'll leave it where we can see it right there. And let's do another example where we find the rectangular coordinates of the given polar coordinates. So you're going to be given r theta. All right, because it told us that these were given, that is our polar coordinates r and theta. What we're trying to do is figure out what are x and y. What are the rectangular coordinates? All right, so now we're going to use what I have written right above, where we find x by saying I've got to know whatever r is and multiply it by the cosine of, in this case, our theta is pi, right? We also know that r value from this ordered pair, our r value is 3. Now, we don't just leave it like that. We actually do it. We can do the cosine of pi. That's -1 from my unit circle. So the x value is -3. Y is r times the sine of theta. So we do the sine of pi, which is 0. And so y equals 0. So the answer for this problem in x, y would be the ordered pair -3, 0. Okay, that would be our rectangular coordinates, -3, 0. Same directions. I'm going to give you something that looks a little different. Okay, now that unit circle is definitely handy if you have it beside you. Okay, so we know this is r and this is theta. We are looking for x and y. So x is -10 times the cosine of pi over 6. Y, -10 times the sine of pi over 6. All right. I can do the cosine of pi over 6 on my unit circle. I get square root of 3 over 2. I am looking for exact values here, not the touch of a calculator. And I get -5 on the square root of 3, not a decimal. The sine of pi over 6 is 1/2 from my unit circle, so y is -5. So our rectangular coordinates are -5 on the square root of 3, -5. These are our x and y values. Definitely using our unit circle. We don't want to type this in our calculator. All right, let's try another. Sometimes my math lab does a little tricky thing and they do this. Now, they told us in the directions, we're still using the same directions. They told us in the directions that this was r and this was theta. Those just look ugly because we're used to theta being in terms of pi. So, on this one, we must use our calculator. Okay, we won't always use our calculator, but on ones like these, we're going to have to. Because x is 8.5 times the cosine of 2.7. Now remember, those are radians. So we are going to use our calculator, but we need to make sure our calculator is in radian mode, or you're going to get the wrong answer. So when you type this in, with your calculator in radian mode, you should get -7.68. This is the only time we're going to use a decimal. Okay, we would have to use a calculator here. Our y value is that r, 8.5, times the sine of 2.7. Again, with our calculator in radian mode, And so y is about 3.63. So our rectangular coordinates would be negative 7.68, 3.63. Okay, now we need to go backwards. Okay, you were given polar and asked to find rectangular. Now we need to know how to go the other direction. Okay, so in this example, we are going to find the polar coordinates. Whose rectangular coordinates, I'm going to abbreviate a little bit right here, are given. So this time we are given rectangular coordinates. All right, we are given rectangular. So this is x and this is y. This time we're trying to find r and theta. All right, so if you have your notes written down in front of you where we described how are we going to find r and how are we going to find theta. Well, r squared is x squared plus y squared. So r squared is 4. Take the square root of both sides, and r is 2. All right, so I found r. R is 2. Awesome. Now I have to find theta. And I'm going to use the tangent of theta is y over x. So I'm looking on my unit circle where the tangent is negative square root of 3. Well, that happens in the second quadrant and in the fourth quadrant. But if you think about this, okay, let's just think for x and y for just a minute. If the x value is positive and the y is negative, then this point is somewhere down here in quadrant 4. So I'm looking for theta in quadrant 4. All right? So where is the tangent? Negative square root of 3 on my unit circle. That's what I'm looking for. And that happens at 5 pi over 3. All right? So we've got our new polar coordinates. 2, 5 pi over 3. All right. Let's try another one. Same directions. I'm going to give you rectangular. You are going to find the polar. Actually, we'll just, let's try one more. I think that's going to be enough. Every time we do these, the process is the same. There's no tricks here. The biggest thing you need to pay attention to is what quadrant you're in when you find your theta. All right, now again, this is not something that your calculator is going to help you do. So you must give your answer for theta in radians, and your calculator is not going to spit that out for you like that. So make sure that you are able to look at our unit circle. So you need to have your unit circle beside you, and you need to have our little rules that we just learned about polar coordinates sitting beside you. So another short lesson for 7.3. Next, we will not be moving on to section 7.4. We'll skip 4 and 5. They're not requirements. So we will move on to section 6 next, where we talk about vectors.